All right, we've entertained how we set up our router, how we assign IP addresses, how we navigate, our different methods of being able to connect, the differences between switching and routing. And now what I want to do is I want to turn more to a theoretical conversation involving how we actually send information in our infrastructure. So let's explore what's referred to as the packet delivery process, because it's going to be incumbent upon us to understand the fact that our devices operate at different levels. We have layer 2, we have layer 3, and each of those use different addressing. So we've already said at layer 2 we use MAC addresses to be able to communicate. Now we have to recognize that our hosts have MAC addresses and our devices have MAC addresses. All of our devices have MAC addresses, and they're going to be best described as burned-in addresses. And I'll show you exactly why I'm making reference to that particular phrase. Now the other part of this is that when we go in, what I want to do is I want to understand the fact that at layer 2, what we're going to do is we're going to be recording those addresses. But what you need to understand is our interfaces have MAC addresses and our devices have MAC address. Let's take a look at that. So what I'm going to do is I'm going to take myself out of the equation. I'm going to bring up my equipment. Now the moment that I find my cursor, so the moment I find my cursor, give me just one moment, what I'm going to do is I'm going to bring up my devices, and I want to take a look at a router. So this is just a router. I arbitrarily picked one. This is R1. So what I'm going to do is I'm going to say enable, and then what I'm going to do is I want to look at some things. I'm going to come in here and say show version. Now the show version command gives me a lot of information associated with my individual devices that I have running, like licenses and things along those lines. But remember, this is a router. If I want to see anything specific to MAC addresses for layer 2 communication, what I'm going to have to do is I'm going to have to show interface. And what I'm going to do is I'm going to say I want to look at G00. Now notice I have a MAC address. Notice it's F70A0, and notice it says the burned-in address is F75538.7, Now what I'm going to find is that I'm going to have different values. So what I'm going to do is I'm going to come in here and I'm going to say, I just want to look at anything that says BIA, burned-in address. So notice it gave me that one command. So let's take a look at gigabit 01, the other interface that I have. So notice that these are just one value difference. So keep in mind, this is the UI, this is the unique organizational identifier, or the organizational unique identifier, the OUI. This is the serial number. So 24 bits and 24 bits. And notice that it increments inside the same device by a value of 1. Now I have other interfaces. Show IP interface brief. See what I have plugged in here. So the only thing I have are those 2 gigabit interfaces. Now what I'm going to do is I'm going to cut over to a switch, and I want to take a look at what's happening with a switch. So on Cat 1, what we see is we have this device. Again, I'm going to go into enable. And once I'm in enable, I'm going to say show interface, and I want to look at gigabit 01. And what we're going to see, just like the router, we have a burned-in address. Notice this address matches this address, and it's 6B01. So again, let's filter our output command. So I'm going to come in here and say include BIA. I'm going to look at it for gigabit 02. And then I'm also going to look at it for fast Ethernet 01 and fast Ethernet 02. And notice what we see here is it's going to be 6B01, 6B02, 03, 04. And it's going to continue that process, and every interface is going to be incremented by 1. But what I want to make you aware of is that switches also have a system MAC address. Now if I want to see the system MAC address on a switch, this is where I can type the show version command. And when I toggle all the way through to the bottom here, what I'm going to find is a base Ethernet MAC address. This is the MAC address that belongs to the switch. Notice it's 6B00. So the first gigabit port was 6B01, second one was 2, the first 2 Ethernet interfaces were 3 and 4. So this is basically the seed calculation for every interface that exists on this particular device. Now, it's going to be very handy for us to know where to find that information, how that information impacts our operation. But we also need to keep in mind that layer 2 addressing is still a very pivotal part of our ability to be able to send IP information. Because remember, the layer 2 of our model services the layer 3. Layer 3 is where networking takes place, but we need to pass that information down to the layer 2, which is going to break everything up into frames. Frames are going to be encapsulated using our MAC addresses. So that's why processes like ARP and things like that are so significant within the confines of moving information across our infrastructure. Now, layer 3 addressing. Layer 3 addressing are those logical addresses. And what we're going to find is that every device on a segment is going to have an IP address. Imagine this is a router instead of a switch. So let's say this is a router, and that's what it should be. It just used the wrong image. Now, what we have here is we have device A communicating to device B. Device A has a IP address. Device A has a MAC address. Same thing for B. Now, what we're going to realize here is that layer 3, we need to use IP addresses. But when we hand it down to layer 2, we're going to have to use those MAC addresses. So what I want to do is I want to explore exactly what's involved in this process with regard to how we can send information when it comes to working with our routers. So the idea here is that we have to recognize that TCP/IP protocol uses the IP stack to communicate at layer 3. So in other words, we're going to be dealing with both types of addressing when we send IP packets. IP packets have to be destined to an IP address, sourced from an IP address, and they also have to be sourced and destined to MAC addresses before we can actually encapsulate information and send it across the wire. Now, this process can get a little protracted, and what I want to do is I want to be able to walk through it, because what we see here is we see a routing table. The moment I start coming in and start configuring interfaces on my router, what's going to happen is it's going to begin populating those connected interfaces as prefixes that actually resolve to a physical interface as their next hop in its routing table. And it's going to be through the maintenance of this routing table that I get the capability of doing layer 3 routing. Remember, layer 3 or routing works at the internetworking layer of our TCP/IP model. So when we look at this, and look at what's happening, what we have to understand here is the fact that we need to do this conversion process. And again, this is something that I'll walk through before. I'll introduce concepts cursorily, and then we'll go into a little bit more details, because by the time I start talking about the nuts and bolts of it, I want you to have a sense of vague familiarity about the technology that we're discussing. And ARP is one of those. Address Resolution Protocol. Address Resolution Protocol, like I said, gives me a vehicle by which I can take a logical IP address and resolve a physical MAC address. So when I go through here, let's look at step 1 of this process. I need the MAC address of whatever computer has the IP address of 172.16.3.2. That just happens to be this guy right here, so I'll just say 3.2. Now when I send this information out, what I'm going to do is I'm going to send an ARP request out. That ARP request is going to say who has the identity of the layer 3 logical address of 172.16.3.2. Now the moment that arrives here, this system is going to say, oh, that's me, and it's going to send an ARP reply. That ARP reply is going to go through the infrastructure and ultimately arrive, which means I'm going to be able to create a routing table on our actual PCs here. So remember, PCs actually route, whether or not you're using a Mac or you're using a Linux machine or a Windows machine, they're all going to populate information associated with how they're going to be sending packets as they affect the network they're installed on. So this ARP addressing process allows me to take and make a map of an IP address to a MAC address. Now, when we go through, what we're going to find here is that there's a lot of steps in the process and in between each of these. So let's look at what's going on when it comes right down to reviewing or seeing what we see. On a Windows machine, I can actually type ARP-A, and it's going to give me the contents of that PC's or that computer's MAC table. MAC addresses are going to be recorded on Windows machines, and it's going to give me the logical address and the physical address and tell me how it was discovered. Dynamic means it was resolved via ARP. Static means I put in a static mapping. Something that we can do on routers. I've never actually done it on a PC. The other thing here is that I can look at the results of my ARP process by typing show IP ARP. Show IP ARP is going to give me information as to the address that I'm learning, and it's also going to have my aging value in here. So ultimately, like I said, these values are going to cook out. This is on a router. This is on a PC. So by default, they're going to actually expire every 300 seconds. And it's also going to tell me how it was discovered. It was discovered via an ARP-A, which is going to be an ARP acknowledgement coming back in the form of an ARP reply. So keep in mind, it's through the discovery of this information that I now have the capability of being able to encapsulate information and send it across my links. Now, what I want to do is I want to look at the host-to-host packet delivery process. Now, what do I mean by host-to-host? I mean from the internetworking layer or the network layer to the network layer on the other machine. So I've got machine A and machine B here. So what I'm going to do is I'm going to communicate between the network layer on both of these. So it's going to be network, layer 2, physical connection across and then back up. So this is encapsulation, this is de-encapsulation. But what we need to talk about right now is this packet that I'm trying to send. Remember, layer 3, the PDU, is a packet. So I have a computer application that's running on this device. This device says, network, I have some data that I need to send to a particular user. That particular user has an IP address of 192.168.4.2, which is this layer 3 address. But the problem here is that when I go through, the application layer is going to send this down to the transport layer. The transport layer is going to say, okay, I'm going to use UDP, which means I'm going to have an unreliable communication, and I need the system to send me the data. So what will happen now is the application layer says, here's the data, and now I've got this packet, or this packet that I need to work with. Now what I need to do is determine what I'm going to do with it. And we're going to follow this through all 16 steps of this particular communication process so that we can see exactly what's happening. So as we go through, remember, we do the encapsulation. So that means we need to add headers. So I'm going to add my header here. I'm going to add my header here. So notice I used UDP. So in other words, at the transport layer, I choose to use UDP, and I'm going to hand this down to layer 3, which is going to be my internetworking. Notice I have my UDP header, I have my IP destination, and my IP source. So when we walk through this, it's going to say at the transport layer, UDP, so I'll add that header in, and I'm going to also say, I'm going to tell it to UDP IP, send this to 192.168.4.2. That's the communication that's being sent down to layer 3. That's where this address comes from. I know my address, so I can actually do the source. And notice, here's my data. Data remains unchanged through this entire process. So now what we need to do is find out exactly what's going to happen with that data. Well, the problem is we don't know how to send the information. We don't have that MAC address. So we're going to have to rely on ARP. So what we're going to do is we're going to take the data, that packet, and we're going to put it in a parking spot. And it's just going to have to wait until we resolve this issue for layer 2 so that we can do this process of encapsulation and serialization. So what we're going to do is PCA, in this instance, is going to say layer 3. I am actually on this network, 192.168.3.0/24, and I want to communicate to a destination on network 192.168.4.0/24. Now the system says, oh, we're on different segments, so what I'm going to end up having to do is I'm going to have to send this to my default gateway. My gateway of last resort. Now in order to make this work, I need to use ARP. So do you have a mapping for this? I'm actually asking this device right here, do you have a mapping? So it's going to send that information, but remember, I don't know where to send that information to. So what I'm going to do is I'm going to use a special layer 2 MAC address that's going to be comprised of all Fs. That's going to make it to here. And it's going to say, oh, do I know about this guy right here? If it does not, then it's going to add it to its CAM table. So it's going to learn sources. But the thing is it's going to say, well, do I have a record of 192.168.4.0/24? If it doesn't, then it's going to do that flooding process. And again, it's going to be sent to the all Fs MAC address. So that means if I had 5 other computers here, all of them would receive that broadcast. The device that actually has the logical address of 192.168.4.2 is going to be the device that responds in this scenario. So again, let's walk through exactly what goes on here. So what will happen here is like I said, it's going to arrive at the router. And the way I'm going to find that is I'm going to send this value that I was just talking about, the ARP. the address. Do you have a mapping for this device? No, layer 2 will have to hold the packet while I resolve the addressing. So that means I'm going to put the packet in that parking space. Step 5. The packet's still sitting in our parking spot. So it's in the parking lot right now. So what I'm going to do is I'm going to create a new packet. That packet is going to be an ARP request. That ARP request is going to say, I am 192.168.3.1. Are you 192.168.3.3? So when we go through here, that's the communication that we're describing between our host and our router. Now when we look at this, what we're going to say here is that we're going to send it to a destination MAC, a broadcast. That's going to be those all Fs. My source MAC address is my physical MAC address. So in this instance, it's 2222 as the last 4. So you can see what I'm going to do is I'm going to hand this down to the frame, and it's going to actually send this destination MAC, which is going to be everybody, source from me, and it's going to have an ARP request. That's ultimately going to arrive here. So when we look at what's happening from the router's point of view, remember our packet is still in the parking lot. We've not moved the packet. It has to wait. But the moment that it arrives on our router, what's going to happen is the router's going to say, I just received an ARP request. Let me add host 192.168.3.1 to my ARP table. I'm going to call that my CAM table, my content addressable memory table, with the MAC address of the last 4 of 2222. Now, what's going to end up happening is when it arrives, this ARP request now has been sent out, and the system here, the router, is going to have to make a determination as to what to do with it. So what it's going to do is it's actually going to look at it and say, I'll send this ARP reply out. Sorry about that. It says, I will send the ARP reply that I am, So it's going to send the ARP reply saying, dude, I'm not where you need to go, but I have the IP address of 192.168.3.2 and my MAC address is such and such. So it's going to be 2222. So that's what we've learned here. All right, and that's the address here. So it says, I will send an ARP reply that I am 192.168.3.2 with this MAC address. So what's happening here is this device is proxying this ARP. So in other words, it's saying, okay, if you, this information, this is the MAC address that I'm actually physically sending, so here is 3.3.3, that's my MAC address, and all it's going to do is say, hey, whoever you are that has this address, or the address that we're looking for, what I need to do is I need you to reply to me. So when we look at the next part of this step, step 8, what we're going to find is that information is now going to arrive on our router. So now this has been 192.168.3.2, which is my gateway address. So what's going to happen, is ARP is saying, I just got an ARP reply from 3.2. Let me add its IP and MAC address to my ARP table. Now what happens is I now have a mapping to reach my default gateway using this MAC address. So now I can actually encapsulate this packet and I can send it. So what's going to happen is the ARP layer 2 is going to say I have 192.168.3.2 and it's mapped to 0800033222, which is the MAC address of this device. And now what's going to actually happen is that we're going to be able to send information. But what we're going to find out is the information that we're going to send isn't going to go end to end. We're going to have all of the information necessary now to take that packet out of the parking lot. And what we're going to do is we're going to send it across the link. And by sending it across the link, what we're going to find is the fact that we have all the information necessary to compile a header. We have the data that we're sending, we have the UDP header, we have the destination IP, we have the source IP, we have a source MAC address, and we have a destination MAC address. So that's going to mean that destination MAC address corresponds to this device. But remember, we ultimately want the packet to get here. So what we're going to find ourselves now is getting the packet on the router, and now what we need to do is we need to make some determinations. So notice right here, it's saying on the router, at layer 2, I just received a frame with my MAC address on it, and I need to pass it on to layer 3. So layer 2 is going to pass it down to layer 3. Layer 3 is going to say, oops, this is not my address. So this address right here, this destination IP address, is not mine. Mine is 3.2. Now, the source I'm going to actually record because it's been received, and I'm actually going to record the MAC address. So when we go through and we start looking at this, that's exactly what's happening. The packet that was sent from A arrived on the router. The router looked at it and it made a determination. So what's going to end up happening here is once it pops everything off, it's going to make the determination that it is not the device that this particular packet was intended for. So let's take a look at the next step. So once that's done, on step 11, what we're going to do is we're going to look at our routing table. Remember, we're a router. So we're going to look at the routing table, the contents of the routing table, and we see that we have two networks. They're both connected, so we're not using any IGPs. So router at layer 3 is going to say, I have an interface on this network, 192.168.4.0. So 192.168.4.2 is where we're going. I know about that network, so I can actually forward this packet directly to the host. So that what's going to end up happening is the router at layer 3 is going to tell layer 2 to send that packet on. So it's going to go through and do the encapsulation process. Now what we're going to find is this packet is ultimately going to make it to B, or it's going to try to. So what we have here is that we have ARP. The ARP address will say that I am 192.168.4.1, and we are trying to reach 192.168.4.2. Now the issue is that notice we now have the packet in a parking lot here because we have everything that we need to send it, except we do not have the MAC address of B in our CAM table here. So it's not in our ARP table. So what we want to need to do is we're going to need to resolve that, and the way that we're going to resolve it is using address resolution protocol. Address resolution protocol is going to allow us to again query the information of all the devices on that segment. Notice we're using the all-lefts broadcast address. Our source is our IP or our MAC address on this outbound interface. Ultimately, the ARP request is going to arrive on host B. Now once it arrives on host B is going to say, okay, I can reply to this ARP request and it's going to send the information back over. And now notice we have the destination MAC address and the source MAC address that we're interested in. Now what we can do is take the packets out of the parking lot and we can actually extend those packets over to the host. So what we're going to do is we're going to unpack it. We now have all of the information that we need. We see that I just got a reply from 192.168.4.2. Let me add its IP address and MAC to the ARP table. Then what's going to happen is that the router, it's going to say layer 2, I have 192.146.168.4.2 mapped to this MAC address. And now what I end up having is I have the information necessary to move this out of the parking lot and shunt it along my infrastructure. So let's take a look at what happens. So on step 16 of this process, ultimately, because I resolved hop by hop the MAC addresses and the destination MAC addresses of my exchange, because the moment I receive a source MAC address, I put it in my CAM table automatically. My destination, I have to send that ARP request out, and then I have to wait for my ARP reply, and then I can ultimately build the information. And now I have all of the information in my router necessary to allow me to do unicast forwarding. However, we have an issue. What's the probability that I'm going to have a host connected directly to a router? Slim to none. So what are we looking at here? We're looking at a logical topology. What's missing? Switches. Ordinarily, we would see switches in this type of deployment. So when we start looking at this, what we've added is another striation of complication. And that's going to be where our switches are going to start creating their MAC address tables. So now let's revisit this process. Just looking at the ARP requests. So what we see right here is that we send a broadcast destination MAC header with our source of A with the ARP request. It's going to arrive on the switch. The switch is going to say, I just received a frame from a host that is not in my MAC table. Let me add it to my MAC table. Well, once it adds it to its MAC table, it's going to list the MAC address and the port that it arrived on, Fast Ethernet 01. Process doesn't stop there. Now what it's going to do is it's going to say, well, since the destination is a address of a frame is broadcast, I'm going to flood it out all my ports, which means it's going to go this way, it's going to go this way. It will not go back out that way. Again, loop prevention mechanism. Ultimately, it's going to be received by the device where it's going to receive a reply. So what we're going to say now is that this is going to arrive with this MAC address, and it's an ARP request that actually reaches this router. Now, what we're going to find is that router is going to deal with something. The router is going to reply. It's going to send its own ARP request. Its own ARP request. So what's going to happen here is the switch, I just received a frame from a host that is not in my MAC table. He's going to add it to his MAC table. So now what we see is the layer 2 information is being built, where this device here is 333.2222, 333.2222 using Fast Ethernet 03. So now what we recognize is now I have all of the information for the switch, such that the switch can be transparent in this process and pass the data between the devices in question. So now what ends up happening is the actual information, the destination MAC address is in my switch table, so I will send the frame out on port FAO1, and what we've done is we've built an end-to-end link between these devices using my switch in a transparent fashion, such that I'm going to be creating this MAC address table that we have up here that's going to be so very important for us, because once it's created, until it ages out every 300 seconds, what's going to happen is communication is just going to take place. We won't have to do any address resolution protocol lookups, nor will we have to wait by placing our information in the particular parking space. So again, this is a lot of theory. What we need to really understand here is that as we go through and information gets relayed between switches and routers, what we're going to find is these devices are going to manipulate the MAC address. It's going to say, oh, change the MAC address to my link, but when you reply, send it to me and I'll forward it to the guy that originally requested it. So again, this is going to be part and parcel of being able to send information, and this is a 30,000-foot view of how IP packets move inside of our infrastructure, taking into account the transport layer all the way down to the network layer initially, and then focusing on the network layer in our last portion of our presentation. I hope that was helpful, and I'll see you guys in the next lesson.